Clarifications Corner. As it often happens, straight after posting the previous video, I received suggestions on how my stuff can be improved from Christopher. And I shall follow the advice. At least on this one. So right here, with Dancing Machine, we only need... this is the pseudo-random generator. And we only need the input once. We only need to seed it, and then it proceeds to work on its own. So this is what this mux was intended for. But of course, we pretty much already have a free switch provided to us by this switchable input. So instead of utilizing a full mux, what we can do is instead turn off the input. So replace the mux with a switch. Doesn't quite fit, but I'll figure it out later. Right, something like this, and then this switch gets enabled while that gets disabled. Actually, let me get a decoder. Might as well, right? Something along these lines. This is a bit cheaper, a bit nicer. I'll wire it nicer as well, but let's check if it works. It does. And the robot is actually moving again. Good times. Let me clean this up. There we go. Same thing, just a bit more neat. No problem. Now, the other part of Christopher's comment is a much more general and I'd say interesting suggestion. It's not something completely new to me, but it's a new perspective on a pattern I've already been using. So you can take a look. So right here, almost anywhere you can use an OR, you could use a switch. So equals 0 would need 9 gates, but less delay than chained ORs. And this less delay part is actually key to me, because I've already realized that you can use switches instead of ORs. So for example, back in say one of my ASICs, let's look at the maze. So right here, I have my one-way things, right? These are effectively a switch, right? They're just a switched output, and all they are is a gray pin or a green pin. They just never get red. And so instead of having an OR construction right here, right, I could have a chain of ORs, you know, OR, well, not here, but, you know, something like this, and then like so, and then like so, right? This would be 3 ORs. But instead what I use is I use 4 switches. And I've actually, since kind of gradually transitioned away from this. I decided that this was wasteful because it is 3 ORs or 4 switches, right? Because we kind of get the first one for free. But something I didn't consider is the influence of this on my delay score. I'm almost always focused on the gate score, but of course delay score also exists. And I think it might be a good idea to, well, if we really want to optimize it, it might be a good idea to go back through a bunch of levels where I use OR chains and perhaps try replacing them with these kind of switch chains and check if, well, check which way is the more efficient approach. But yeah, like I said, I've if we take a look somewhere else, I think in Tower of Alloy, it'll be visible. Yeah, I have actually transitioned to using OR chains because I decided this was cheaper, right? So these are just custom shaped ORs, right? And instead of having 3 one-way or 4 one-way things, instead of having this kind of construct, what I do is I do ORs. But yeah, I didn't consider the delay at all. I was just thinking about gates. And Yeah, I might want to eventually go over some of my stuff and replace that. But I'm not going to do that now. This is not going to fit into Clarifications Corner. That is just an interesting comment I wanted to mention. Right now, water world time? Final level. Well, the intended final level. My final level is going to be AI Showdown. But like I said, I still have a bunch of stuff to do. For now, let's still proceed with more assembly challenges. Okay, good news. You want to turn Earth, small e, lowercase e, into an exotic water park. We need you to help us find a good location for the Pirate's Plunge water slide. Specifically, we're looking for an area that can hold a high volume of water. Okay. The landscape is 16 columns wide. I see columns, yeah. This is very Minecrafty. Read the input 16 times to get the height of the landscape at each column from left to right. Okay, no problem. Then output the total volume that the landscape can carry as the answer. The total volume of water, I assume. Okay, wait, is that not trivial? Don't I just, like, sum it all up and that's all? Hit enter to show water. Oh, wait, yeah, okay. No, I do not. I cannot just sum it up, because... Well, first of all, we don't have anything supporting water on the sides. But even then, there's stuff like this +3 here. Which water will just overflow and get out. Right, so I'm imagining we get a uniform downpour of water from every column. And it continues for a while. All the water that can escape escapes, and then what we end up with is our result, is our answer. And I need to detect how much. Right, I need to detect, yeah, total +5, +2, +1, +5. Sure, I see. Okay. This. Not gonna lie, this sounds challenging, actually. This sounds challenging. Give me a few moments to think about this one. Okay, so what I'm thinking immediately is there's gonna be pools, right? This is a pool, +5, +2, this is a pool. +1, +5, this is another pool, then another pool, and this is another pool. And the important part is the water level in a single pool is going to be uniform, of course, because it's water. But the pools, different pools might have different levels of water, and that is the problem. So really what I need to try to detect is I need to detect the difference between pools. I need to detect where pools start and end, and I also need to figure out the water level in a pool. Now, obviously, the water level in a pool is going to be the lowest of its two boundaries, right? Yeah, it's gonna be at the lowest of its two boundaries, right? So for this one, we have a large column on the left. It's like 5, I think, 5 tall, maybe 6. 1, 2, 3, 4, 5. Yeah, so 5 tall here and 3 tall here, and the depth of this pool, the water level in this pool is 3. While in this one, well, okay, so I would call this water level, I would refer to them with absolute values, with absolute heights. So this would be either 3 or 4, depending on whether we count this lowest line. And so this would be 4, 5, right? This would be water level 5. This is also water level 5, and everything else is water level 5. Now, the challenge is I do not know which side of the pool is going to have the lower column, right? I cannot just say go left to right and from here say, all right, we have a pool and it's this water level. No, I do not know that, because when I reach this tree, right, when I reach here, if I assume that my pool has water level of this tree, so water level 5, then we're gonna have a problem, right? I'm gonna count too much water here. So I kind of need a way to detect... it's not even that. It's not even just detect. Right, I'm immediately thinking of the difficulties of managing memory in assembly, and in leg specifically. Like, it doesn't seem like I can do this in one pass. It really doesn't. Because, right, I cannot... Actually, maybe I can. So... I'm not... I seriously doubt anything fancy is going to be necessary here. Just like with, you know, the sorting level, where we realize that the biggest difficulty when writing solutions for these kinds of problems, small ones in assembly, the biggest difficulty is just the overhead and not the asymptotic complexity of the algorithm. So I don't think we're going to want anything complicated at all. We're not going to want any kind of, I don't know, recursion or sliding window stuff. I don't know, like some kind of binary search on a linearized 2D array or whatever. I don't know. I think what we want is the simplest, most basic approach. And what I'm thinking is, I do want to scan left to right, or right to left, doesn't matter, but let's say left to right. And let's not think about how I detect these peaks. Let's just say I detect that I am looking at a pool. Right, so this is probably a pool. I'm not sure what its height is yet. But what I do is I count the negative space of the pool. Right, I can count 1. This is the height of this column. Then I can count this one. This is going to be the negative space of the pool. And then once I find, I don't yet know how, but once I find the right boundary of my pool, this thing, I can establish the water level, right, with these, knowing these two heights. And then knowing the water level, I'm going to be able to calculate the total area. And then water is going to be total area minus negative area, right? I don't know if I'm explaining it well. It kind of sounds okay. I don't think I'm going to need a whiteboard for this explanation. Right, so that's the basic idea. And now the question is, how do I detect... Is it going to be easy to detect boundaries? Well... Okay, so let's say... so anytime I see a high column, and then to the right of it is a lower column, anywhere, doesn't matter, here as well. Anytime there's a lower column to the right of a high column, this means that we are potentially looking at a pool. It might spill over, but it's probably a pool. And yeah. Now, if we're looking at a thing that's higher, that is not necessarily right. If so, we're scanning left to right again. Say we reach here, we found a high column, a tall column, then we see a lower column. But and we start counting this as a pool. Next we see another column. It is higher than the previous one, but I don't actually care until either I run out of space completely, right, until we're here, or until it actually gets taller than this one, I think, right? That's the end of the pool. If we never get taller than this thing, and we never run out, well, that's impossible. At some point we will run out. Yeah, but until we get at least at the height of our left boundary, we are making a new pool. It's pool, 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 pool. We're guaranteed that it's a pool. Okay, okay. Actually, I'm starting to like this approach. Sounds fairly decent. Pretty simple, and it might even work in one pass. Like, I think I can process data as I'm reading it, actually. Okay. All right. Let's try. Import. There. Okay. So, what are we gonna need? I'm gonna want, let's say, I'm not sure what to call these things yet, but let's say left boundary or left wall, left shore. Bank. I looked up synonyms. Bank. I like bank. Left bank. Right. We're gonna be keeping track of where our left bank was. I think I might also want something like const in pool. You know, whether we are actually counting a pool right now. And we were gonna count negative space. So let's say neg space. ABC. And I don't know, let's say current. D. Or we'll see. Okay, so let's say in pool is going to be a boolean, right? And we will say that we start we start not in a pool, definitely, right? Because we're on the left side. This actually doesn't need to happen because false is 0 and we are 0 initialized, but just for my own sanity, let's put it here. Now we're gonna, let's not worry about the loop for now. Let's just load. So mov io and it's current, right? So new thing. Okay. Now if current is less than left bank, right? If current is less than left bank, then we're gonna be start counting pool, right? This means I kind of want to initialize left bank. So let's, for now, let's say save, I don't know, infinity to left bank, right? Now, this is going to be pre-init phase, or just init. We loaded. Now, if current is less than left bank, then start counting pool. But that's not actually all, because I also need to take into account whether or not I am counting a pool right now. Right? Am I? Do I care? Okay, let's take a look at the else of this. So else, what's gonna happen else? else we know that current is greater than left bank. So we are kind of climbing. Well, then we have a new left bank. Left bank equals current. However, that's not all, because I also need logic for pool counting. And in this case... Ooh, this is... haha. If current... Then, yeah, if we're... Actually, if we're lower than... Start counting pool, but also actually count pool. So negative space plus equals current, right? Something like this. Otherwise, so this is not necessarily, it's actually, no, it is right. This is our new left bank, but if we were counting the pool, this means that we found right bank, right? Which means something like water level equals minimum of left bank current bank and, you know, calculate pool size. Whatever, it doesn't. This is fine. I think this is about right for pseudocode. Let me reflect on this for a moment. Well, I'm not sure what this does now. So start counting pool doesn't really matter. Like, over here, after calculating pool size, I'm gonna need to, you know, I'm gonna need to do total size plus equals pool size, and then reset pool, right? So pool size is gonna be 0. That's gonna be this. And I don't actually think I need this at all. So it's kind of like, yeah, this is just counting pool. Yeah, so in pool, this thing is literally current is less than left bank. I think that's right. Seems okay. Minimum. I'm not sure how I'm gonna implement minimum in assembly, but we'll see. Okay, I guess let's try to write this. Do I want something clever with this if-else construction? I hate if-else in assembly. Give me another moment. Oh, also, I just realized one thing I didn't take into account is the end of the thing. But I think I'll just get a right bank of height 0. Just gonna zero me out. Yeah, except no. I cannot detect it as my... Yeah, I'm gonna need something clever here. That sucks. Okay, give me another moment. Okay, whatever. Let's not overthink things. I am prone to doing that. Let's just implement this if, except as we know in assembly there's no straight if, there's an if not. So if not left bank less than equals current. Oh, I'm already confused. I hate ifs in assembly. Bring me back my if. Where's my actual if? Okay, let's just write something. So this is terrible. If unsigned less than current left bank, then we're gonna be jumping. Where? We're not gonna be jumping anywhere. So no, I do want unsigned list equals left bank current, right? And then we're gonna be jumping to else. You know, done, pool done. Pool done. Is this right? Is this condition right? So if left bank is less than what I found, then we're done. Yes, that is correct. Okay, so if we're not done, then we're gonna be incrementing our negative space. So add current negative space, right? And that's about it. Now I just need an unconditional jump. Where? To, I don't know, done. done. We'll see. Label done. So I will need to jump over the else. However, over here, you're gonna need water level. Okay, what's a minimum in assembly? I could do a jump construction, of course, you know, if less than, then I could also add a hardware instruction, and actually that would be, I would be inclined to doing that as opposed to doing jumps. Do I still have space for minimum? Oh, I have plenty. I have plenty of space. Yeah, so I might do that. What other options do I have to implement a minimum? And do I even need a minimum? Do I even need a minimum, or perhaps? Wait a minute. I don't. Okay, this is actually very wrong, and this points out, I think, an error in my approach. Because I know, at this point, I know which of these is the minimum. Right, if I am here, then I know that left bank is minimum. I know that I found a larger thing. Oh no. Oh no, none of this works. Yeah, this assumes a huge right wall. This assumes a huge right wall propping the water. This will not work. This will not work for this. Oh no, oh no. Abort, abort. Abort algorithm. Right? I will never find this pool. I will never find this pool. Actually, no, I think I can still... Aha, I think I can still adapt. I can still adapt this approach. So, something I failed to notice is a possibility of a separation of the pools by a smaller thing. It's a shame I don't have a better example here. Huh. So what I'm thinking is I could try to keep track of my best candidate for the right bank. But, oh no. Okay, give me a moment. Man, I don't know if this approach will work at all. I'm starting to doubt it. So if we take a look at this middle pond, right, this one, the biggest one. With my approach, I start here, right, this is my left bank. I go down, it's fine. I go down, it's fine. Then I go up. And at this point, in order to know whether this is my new right bank, I actually need to know pretty much everything to the right of it. See, because if there was nothing here, so say this was completely flat, then I would know that this is the end. This is my right bank. And oof. That is a big issue. And it actually doesn't work in multiple ways. Even if I were to detect it as my right bank, since my left bank is considered to be this, it's actually too high. And I'm kind of trying to count this as a piece of water, but it doesn't fit at all. And instead, this thing is going to be added to negative space. And yeah, I'm going to get a completely wrong result. So, oops. I mean, I never said, I'm pretty sure the first thing I said was that this didn't seem easy. But yeah, it looks like I'm gonna need to do some thinking on this one. I'm immediately starting to consider other traversal options, like maybe, perhaps I could start it in the center and then expand both ways out, you know, to the left and to the right. But that also doesn't seem right. That also doesn't seem helpful. I could do some kind of recursion on new pools. You know, is this a pool? Is this a pool? Is this a pool? And then it all kind of folds on itself once we reach the end. But yeah, these are both vague, and I'm not sure about the second one, but the first one does not seem actually helpful. It's just an idea. But yeah, still a linear approach seems like the best thing, because I really do not want to deal with keeping all this in memory and then iterating over it and trying to you know, do something with it, because yeah, memory access is expensive. Even with my immediate memory, I still need to load it into pointer. That's an issue. So I would be inclined to still trying to implement something that goes left to right. And yeah, if it has to be that kind of recursive approach, then maybe recursive. Or maybe I'm just missing something, and it is possible to detect a pool neatly left to right. But, oops. So something else I wanted to say, of course, this is a symmetrical system in a way, right? The water flows both ways. And it does intuitively seem like an issue if I try to go left to right. Right, I don't know what the water did on the right. And it actually did the same thing on the right as it does on the left. It flows to the right in the same way it flows to the left. And just intuitively, that suggests some kind of symmetric algorithm that treats water flow equivalently whether or not it goes left or right, while my thing doesn't for now. So yeah, this is interesting. So another thing that comes to mind, especially in the context of the symmetry of water physics, is maybe something like a 2-pass approach. I could do something like my original idea from left to right, and then I could do the same thing right to left, right? The exact same thing, in fact. And then somehow combine the two results. Because it is still kind of correct. The approach, I believe, is still correct, so long as there is a higher thing further, right? If we had a wall up here and a wall up here, then I think my algorithm would actually work. It would actually be correct. Yeah. Actually, well, yeah. If we had a wall up here, my algorithm would be correct, assuming water flows out into here. And going right to left, and assuming a wall is here, we could do this. But then the intersection of the two might be the actual result. But first of all, that's still difficult, and second, I'm not sure what the intersection, air quotes, algorithm is. And there are no walls, but still there is this kind of idea that my algorithm holds up until the rightmost highest point, right? Of the high points, of the highest points up to the rightmost, my thing works, but then it breaks at the end, right? And if I could, for example, I could find the highest point, right? So if we imagine that there was a super tall column in the middle, then I could apply this, and then I could apply this, and sum them together, just relative to some middle. And this would work for this, but I would need... See, all of this is a lot more complicated. I would need 3 passes, pretty much. Would I? Yeah, I think I would pretty much need 3 passes, because the first one I would need to find the top, then up to top, and up to top. Although actually, like in terms of passes, I could... No, I couldn't. I was thinking maybe I could combine left and right, you know, so iteration 1, this and this, then iteration 2, this and this, then iteration 3, this and this. But if they need to meet around here somewhere, then we're gonna have a problem. But yeah, something is there, I think, in going from both directions somehow, closing in on the center. It's kind of a variation on what I already mentioned with spreading out from the middle. You know, starting at the middle and spreading out, but I think going from the sides is easier. But still, I need to try to come up with something better, maybe. Yeah, I can't really come up with anything better. I think I will end up going with some variation of this kind of 2-pass, 2-way approach. Now, this is still, like I've already said, of course, this is still correct. And in fact, like I could even do this in 1 pass, air quotes, with pre-processing. It's just, the problem is I cannot detect this if correctly. I cannot detect my right bank, because there's two options for what a right bank is, right? We can easily detect one way in which a right bank can be found, which is if it's higher than my left bank. But if it's lower, it might still be the right bank, but the condition for this, really, is this is the highest of everything that's left. So there might be a million things to the right, but the necessary thing is, in order for this to be my right bank, this needs to be no lower than everything else to the right. And in order to know that, of course, I need to first know everything to the right of it. So that does mean that I will necessarily need to read my entire input first before I can actually calculate the result. So there's kind of two approaches I see. The one is, as I've already outlined, try to find the maximum. So, I mean, I imagine I would just do that in line with going left to right. So I go left to right, left to right, left to right, left to right, until I find my last highest point, right? I remember this one. I discard everything else, so I don't count water from here. And then I would start from the back. Well, I would read everything, but then start from the back and go up to this peak, right to left, and then add two results. So that's one. But also, one more thing is the way I just explained it. The detection of right bank is contingent on this, property that it is no lower than everything to its right. And so something I could do is I could calculate exactly this statement for each peak, right? I could go right to left and I could calculate, okay, this one, it is correct of this one, it is true of this one, that it is no lower than everything to its right. It's also true of this guy. It's also going to be true of this guy. It's also going to be true of this guy. But it's not true of these guys, right? And knowing these basically booleans, I could actually just do again, air quotes, one pass with this, except my if would be more complicated, right? I would not just detect higher right banks, I would also be able to detect lower right banks from knowing this. So let me just consider which of these I'm gonna go for, and then I think we can get back to some assembly. Actually, thinking about this peak idea some more, the multiple peaks idea, this one, I think I may have come up with a more elegant solution. It might actually be the most elegant so far. So, the thing I dislike the most about my original suggestions is the kind of sort of asymmetry of them and the, I don't know, non-closed form. The fact that I need to go left to right, I need to preserve state, and then I need to go right to left, preserving some state. And it's kind of different things I'm doing on the first pass versus on the second pass, where on the first pass I'm saving booleans, and on the second pass I'm actually calculating water. It doesn't seem to make much intuitive sense, and instead it seems like you should be able to just look at a column of water, and you should be able to know how tall it is, right? And really, if we look at it, for any column, the water level at that column is gonna be the minimum between the tallest column that's on its left and the tallest column that's on its right. Everything else doesn't matter, right? What matters is what's the tallest to our right and what's the tallest to our left, right? And that is actually my water level. This is kind of a closed form solution. I don't need to keep track of a pool. I don't need to keep track of negative space. I will just be able to tell the height at every point. And this is kind of based on the peak approach, on the multiple peaks approach. And just instead of saving booleans, when I go left to right, I'm gonna be saving for each column. I'm gonna be saving the highest column we've seen so far, which is the highest column to its left, right? And then when I go right to left, I'm gonna be doing the exact same thing, except now I don't actually need to save, but still I'm gonna be calculating the exact same thing. I will be calculating the highest column yet seen. And yeah, from the two, right, I will have the highest to the left saved. I will have the highest to the right currently in my possession, currently in context. I will be able to determine the minimum, and that will be the water level for that particular column. And that's actually very neat, I think. Let me check for deficiencies in this approach, and then we can get back to assembly. I see no deficiencies. Either my approach is flawless or my reasoning is flawed, but I'm ready to go with it and I'm ready to try to implement it. So yeah, I've removed everything. I think it's going to be easier to start anew pretty much. And okay, so I'm gonna... it's always... What variables do I want? Well, let's not worry about that. For now, let's see what I need to do. I need to save my... Since I'm doing a 2-pass approach, I'm gonna need to save my heights, right? So I'm gonna be doing something like mov io to... well, actually, do I want to put it... I could put it in RAM, or I could put it on the stack. But I will also want... So I will want multiple values saved per pass, right? I will want, for each of my columns, for each of my initialization steps, I'm gonna want to both save the actual input, because I will need it for the processing on the second pass, and I will need to save the highest encountered so far, right? So something like left high. And I mean, either approach fits, or rather, I could use RAM or I could use stack, but I don't want to use exclusively RAM for this, because that'll saving 2 values will involve pointer operations, and I want to avoid that. But the stack is problematic because I won't be able to load from it multiple times. Oh, and also, actually, I also need to keep track of how many columns I've seen, right? Yeah, I will need to load 16, and then I will need to know to stop trying to load from IO. So I'm still going to be incrementing a pointer, so I think I might as well use the pointer and RAM. Yeah, that sounds good. So, well, let's just say I'm saving my stuff to RAM. So the actual inputs I'm saving to RAM, and then I'm gonna be incrementing. So immediate to add pointer 1 pointer, right? I'm gonna be incrementing my pointer, and I will continue doing this until I reach 16. So jump if unsigned less than, I believe, right? We start from 0, we reach 15 actually. Yeah, so less than pointer 16. Immediate to, right? Pointer less than 16, and we'll jump to init. Okay, so label. Come on. So this is our init phase. But this is only part of it. Okay, the addition needs to come last. Now that I have loaded my IO, I will need to keep track of, okay, const, I'm gonna call it left high. Right, so left high starts out as 0, yeah, and now if what we just loaded, unsigned, actually, do I want less? It doesn't matter. So let's do, I'm just thinking, do I want to do more jumps or fewer jumps if it doesn't matter? Not sure if you even understand what I'm on about. Can't be bothered explaining it. So, okay, unsigned less than. If what I have just loaded, and I just loaded to RAM, and yeah, so this is a cool part about RAM. I can load from it without popping. If I have just loaded a thing that is smaller than my left high, then I haven't encountered a new high, right? So label, no, I don't know, something like this. Haven't encountered a new high. And I'm going to push my left high to the stack. Yes, I am using both RAM and stack here. So move left high to stack, right? So I didn't need to do a RAM operation, and instead I just pushed the stack. And I won't need to load this multiple times, hopefully. I don't know. We'll see. But here, if my new thing that I loaded is actually greater than or equal... No, less equal. If my new thing is actually greater than my left high, then I will want to update my left high, so move RAM to left high. Right? Does this seem correct? I think it does. So this is actually our first pass. And on the first pass, what we have is in RAM, we have the actual heights. And at corresponding positions on the stack, we have the highest thing encountered so far from the left. Left highs, actually left high. Hey. Yeah, that seems fine. So now label. I'm not gonna call it init. I'm gonna call it pass 1. I don't know. Actually, left pass. L pass. Haha. Right, and then label right pass. It's gonna be very similar, except we're not, well, no, it's not gonna be that similar, but it's kind of equivalent. We're not moving from RAM. We're not moving from IO. We are, in fact, loading from RAM. I don't need to reset my pointer. My pointer is already... Ooh, this is nice. Yeah, my pointer is already at the end. So I don't need to reset it. I'm going to be descending. So let's just say here I'm going to be doing unconditional jump. No, I'm not going to be doing unconditional jump. I'm going to be doing jump. Actually, immediate 1. Unsigned less equals 0 pointer. I will want my pointer to reach 0 until my pointer is greater than or equal to 0. I am looping, and every time I'm gonna be immediate to subtracting 1 from my pointer, right? So that's this. This means I'm pointing to a good location in RAM. Oh, and now... Huh. Okay, I'm thinking ahead again. Give me a moment. So I'm gonna want to keep track of right high. And actually, I don't need low high anymore, so I'll just call it high. I'll also call it max, but whatever. Right. Although... I do need to reset it now, which sucks. No, I changed my mind. I'm gonna use another register, but save an instruction. So we're gonna have a right high now it's 0 initialized for free. And I'm doing pretty much the same thing, at least here. I'm gonna be keeping track of right high, right? No right high. Right high, no right high. So I already have my right high. But now what I need to do is I need to calculate, right? So water level is equal to minimum between right high and low high, L high, which is, at this point, stack. Do I want to implement? I don't think it's possible to... Yeah, I'm pretty sure it is in fact impossible to implement a minimum operation in assembly without hardware changes that reads from stack without using an intermediate variable in which to save the value from the stack. Because I need to compare the stack to right high, and then I will need to save one of these, which means I might need to access stack again. I am tempted to go implement a hardware component right now. I am seriously tempted to implement a minimum and a max while we're at it, I guess. Should I do that? Nah, you know what? I'm gonna stay on assembly for now, and we can do hardware later. But while we're focused on assembly, let's not get distracted, and let's just use a. Well, actually, I don't need anything new. I can just load. So, mov stack. It's like I'm gonna leave myself a to-do comment. Implement min. So I'm gonna move from stack to left high. Yeah, and now it's gonna be minimum between left high and right high. Ooh, yeah, this is shaping up. So now, this is gonna be an ungodly if construct, but jump unsigned less equals left high, right high, water left, label water left, right, otherwise water right. So we're gonna do mov right high to water level, const water level ABC. Kind of using inconsistent. I use a very verbose name for water level and then WL. Whatever. Right, and I need to unconditional jump over my else, or rather over my if. Bye. You know what? We're writing bash now. Bye. Right, and here mov left high, water level. Right. And now, so now we have water level is minimum, right? So unsigned less equals if left high is lower than left high, otherwise right high. Yeah, perfect. So we have our thing in water level, and all I need to do actually is just do subtraction. I subtract from water level the height of my column, which is RAM for me right now. Let's put it back into water level because why not? And then I add water level to result. Something like this. const result abcd. Okay. Is that actually it? Seems alright. It is of course gonna be broken, but mov res io. Let's run it. Let's see what happens. Can't exactly tell what's happening. Oh, it looks like I'm jumping. Where on earth am I jumping? Why am I jumping to PTR? Jump to right pass. R pass. Okay. Let's see. Right pass. What's taking is what? I think it's looping over the entire RAM or the entire program. Yeah. What? Oh, pointer. It was pointer. I just forgot to add the label. Okay, how about now? That looks more promising. But also... Wait, what's my pointer? Oh no, my pointer is 200. How on earth did I skip the 0? Immediate 1, jump, less equals 0. What? Oh, you're always less than or equals to 0. Wait, how do I even do this then? I do want to, so I think I need like 255. Is that right? It's really weird that I need this. It's really weird that I need to make use of overflow in my assembly. But I think it's correct, and I think it's actually the only way to implement this. No way. That's super weird. That's super weird. Oh well. Let's run it now. No. I overflowed again. What the hell? 16. Unsigned less. So long as I'm less than 16, I need to keep going. Okay, that time it worked, but I'm gonna see what actually happens. So 8753. Okay, so we do stop at 255. The correct volume is 28, and I output result D A B C D 22. Okay, that's not too far off. But what I do not like is I do not like a water level of 252. How did I get a water level of 252? Right high water level, left high water level. So I must have saved something to my water level. My left high is already here. I can actually think it's nicer to put it here instead. Right, because this is kind of part of the minimum. So I calculate right high. I think I do it correctly. Yeah, like if I encountered something new, then update right high. Otherwise, right high just remains unchanged. I don't need to write it the way I do here. I'm loading from stack in the correct order. So what is up here? What's up with water level? How does it get to that high number? Subtract RAM from water. Well, apparently it overflows, I suppose. RAM from water level. That's weird. How does it? Okay, I guess let's try to trace it. I'm gonna do some live debugging here. usually cut it out. I don't know. Maybe I should. So, okay. We are now at this column. Let's first just check where it starts to overflow. So I'm looking at what register again? Water level C, A, B, C. I'm looking at 2. 0. 4. 4, 3. 3. 6, 0. 6, 1. 6, 0. 6, 4. No, it looks okay actually. It looks okay. Does it just overflow on the last pointer? On pointer 0? Or something? Did I mess up my pointers? So pointer equals 0. Ooh. Wait, it just overflowed. I didn't notice. How did that happen? What? So 2, 3, we're here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Huh. Why does it break here? And it's not even the last iteration, it breaks over here. Right, there's still one more iteration to go. But it actually remains. Wait, is my right high correct? Or left high rather? What am I saving to stack? Let's see what I'm saving to stack. So, can I? Okay, maybe I should cut this debugging out. I'm gonna be back with the solution. I admit I'm still confused. It seems to go through the right solution and then proceed. So, right now, we are at pointer 2, right? And this is the result, 23. This is the result register. Right, we're gonna get to 28. And then it all goes wrong. At pointer 1, we are doing something weird here. We are subtracting 2. Yeah, and then it all goes wrong. But I don't understand what's so special about pointer 2. I really don't get it. I think I know what the problem is. Problem is my pointer is not synced up with the stack, and overall I think my pointer is very wrong. So at the left pass, I wait until the pointer reaches 16, but actually the largest position in RAM I've put something into is lower than 16, it's 15, right? And then I add 1, right? I've put something, I add 1, and then I decide, okay, we're done, I'm not proceeding anymore. So I might, yeah, it looks like I will have to reset my pointer. Or, you know, I could do subtract or I could do set. I'm gonna subtract. I don't know why. Subtract from pointer 1. Right, so this 1 that I added at the last iteration is wrong. And now, oh, actually, you know what? Oh, wait. Check this out. And that also solves my issue with the weird less than. Cool. Right, so now when the pointer reaches 0, I am actually done. So unsigned less than, yes, 0 pointer. Cool. Yeah, this is much better now. Yes, perfect. I expect this to work. 15, 20, 28. Haha! Great success. Enter. There's some water. Still pretty simple landscape. My algorithm is capable of more. It's a shame you can't hit enter and have the program still going. Ooh, yeah, this is a much more interesting landscape, but still, we should do quick work of it. Yeah. Okay, this will be 0, no problem. No, I think the actually, yeah, this kind of thing is an actually interesting landscape. That's the same, but oh well, we have a generic solution for any kind of landscape. Cool. Cool. Oh, there's 128 tests. We're not gonna be sitting here that long, but I just want to see. I want to see one really difficult one. I think the hardest one. Okay, I'll just show it. I think the hardest one, air quotes, is something like this. You know, with a huge spike in the center, and then it just peters out. But you have all these different water levels at every point. All right, let's see our score. And I think I might implement minimum right now. Hello? Did you crash? No. Water World! Beat the level Water World. Steam achievement get. Score 4000. Yeah, I'm gonna be implementing minimum now. Now, implementing min and max as hardware instructions is going to be an instance of a task that is optimizable, but in a way I dislike. In a way that breaks separation of concerns, in a way that breaks compartmentalization, if I can pronounce the word. So the way MINMAX would work, at least this is pretty much the only way I can see, is we just compare and then we switch which output we want based on the result of the comparison. And the thing is, we already have a comparison in a cont, right? We already have this component, and in fact it happens every single time on every pair of inputs. It does get carried out, this one, right? So I wouldn't even need to enable it in some cases. I wouldn't need any special logic. It's always there. This comparison always happens. But the thing is, in order to use it, I need it in the ALU. Because of course, min-max are gonna be an arithmetic operation, right? It's a function from integers to integers to integers. And this means that either I merge these two elements into one, these two components, and I have a advanced ALU conditional block, right? And then I can just work inside there, or I can unfold them and use them as is, or I add another output to a cond, which I bring all the way back here, and I pipe it into the ALU, and then here I can use it to make a decision which is min and which is max of these two, right? I am not happy with this. I am opposed to that solution, but I'm pretty sure there isn't any way around it. Well, other than just plopping a whole other... How costly is it? 54 gates, other than just plopping an entire 54 gate unsigned less than component into here, which I mean wouldn't be that much of an expensive thing to have on an architecture that already costs 2,700. But you see, when I can avoid it, it's really hard for me to justify spending gates. Yeah, and actually I've looked it up already, and it seems like pretty much every single real existing architecture has min and max built in as hardware instruction. Even RISC, you know, the supposedly reduced instruction set computer, still implements the instructions for min and max, at least from what I can tell. Some variations of it do. So it seems like a good idea. It seems like a thing I want. But I just cannot decide whether I want to spend the 52, 53, whatever gates on not adding this wire. I mean, to be fair, there are a lot of other similarities between ACOND and ALU, and I think there's a lot of other redundant things here. So, for example, if we take a look at the instruction, right, these 4 bits get decoded here, but also in the ACOND, these 3 bits get decoded. So these 2 decoders are redundant, right? If I were to put them in the same component, I would be able to save on the decoder, and yeah, there's a lot of other things, I'm pretty sure, where I could save more stuff. You know, just, yeah, all over the place. It's always possible. But I think I'm gonna hold off on that. And I'm just gonna pay the price, and I'm gonna use another huge component. But actually, yeah, let's design an actual min component. This is gonna be a base 8-bit component, min. It should be fairly simple. Let me lay down the basics. Okay, so I think I want this kind of interface. I want input 1, input 2. I will have my output as the min or max. And yeah, they're gonna be fused min-max. Let's just literally call it min-max. Like this. So I'm inconsistent in how I use caps versus not caps in these names, but oh well. Yeah, and this thing is gonna be switching between min or max, right? So by default, if it's off, then we're min. Otherwise, it's max, right? Because I definitely do not want to use the less than component twice for the min and for the max. So yeah. Right, so it should be pretty simple, right? We just take this. This is gonna be our comparison. I don't actually care about equals. All I care about is less than, right? How am I gonna min-max? I'm thinking, how am I gonna do this one? Kinda need a conditional not on this, right? What is a conditional? Do I have a conditional not? Yeah, it's an XOR, is it not? Yeah, a conditional not is an XOR, so something like this, right? And then these guys, they will be chosen between using a mux. Something like this, I think. I might have messed up my nots. This might be reversed, but let me just test this and fix it up. Yeah, I did wire them backwards. So I need this guy as the bottom of the mux and this is the top of the mux, but it's pretty simple, don't even need to bother. I'm gonna clean it up, but right now we have 24, 56. We are in minimum mode, so 24. If we flip, 56. That's about it. I'm just gonna clean up the wiring of this and we can proceed. Thing along these lines, this should do. Now, obviously, this is itself a bit wasteful because I'm not using this pin, which means I can remove all the logic related to this pin, which means this stuff, a single end can be saved here. But we're already being quite wasteful even defining this element, so... I mean, now that I say it, of course, I might want to use a min-max in an ASIC, and then it's kind of worth it, but still, whatever. Let's just keep it this way. So now I need to add it to my ALU. We go here. Where's my min-max? There's the min-max. However, oof, tight space. Nothing fits. I don't want to grow the ALU too much, but it looks like I have to. Oh well. Yeah, so we're gonna add 2 more instructions. First, we're gonna have a min. And second, we're gonna have a max. Oops. Come on. Right, and if we are in max mode, then I will want this thing enabled. Right? And this is gonna be my output. To both. Right? I think that's right. Am I being wasteful here? Maybe on the switches a little bit. But again, this is keeping with the setup I've had so far, so I'm not too worried. Right, and now all I need to do is I need to bring these down. Which is the first and which is the second? So this is the first, and this guy is the second. Okay, so now we have a min-max. The ALU is now a little bit huge. But that's fine, that's to be expected, especially if I intend to add more operations. Oh, you know what I could do? Right, I can... it's not actually gonna save me much in terms of the shape of the component, but it's gonna save me this vertical space still, and that's good. Except, why... Oh. I don't like that. Yeah, that's better. Thank you. Cool. Cool. So there's the new ALU. No, still not yet. Okay, I should have cut this out, but too late. This was removed. That's fine because it needs more space. Yep, perfect. There we go. We have our ALU. And now I just need to check what number is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 minimum, 11 maximum. Let's add this to the instruction set. 10. What's a 10? Min and 11 max. Okay, and let's replace this stuff. I'm too scared to remove it for now because I don't know if my max will work. Right, I don't need any of this anymore. Now all I need is I need max between stack and what is it? Write high into water level. I actually don't need to use water level, I don't think. I could use stack as well. Yeah, while we're at it, actually, no, let's test one thing at a time. Oh no. Wait, it's not max, it's min, of course. Still broken, okay. It looks like my max might be wrong somewhere. What did I output? Oh no, 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 no. Something is very wrong. Something is very wrong. Why is something very wrong? I'm especially surprised by the fact that this thing is overflowing. Yeah, this makes no sense. Okay, let me debug. Oh, well, here's one. I need to actually connect to the min-max to the output. Let's see now. I've made some test cases. Just very simple ones. 26 is the minimum of 26 and 6, 26? Seriously? Damn it, it's all reversed. Be right back. Right, I counted this wrong. I started counting from 1. So, and I should have started counting from 0, of course. And this means that my instructions are offset by 1. Which means that here... max is... well... min is actually... wait. Yeah, this is actually max. Oh no. Yeah, so 10 is max, and then I need a 9. That is min. Yeah, max is 10, and min is there. There. Let's see now. 6, 26, 26, 122. Perfect. Okay, and now I expect the program to work. Yes. Great success. There we go. Now we have a minimum. Our score is worse now. Oh man, that sucks. I didn't save anything. Oh, that sucks. But no, I'm not optimizing that. I should probably keep the efficient solution without this commented out. And yes, I do intend to make an ASIC for this, as well as, of course, well, I don't think I've promised this before, but I do intend to at least try to make ASICs for everything. I am dreading the ASIC for robot racing, because recursion, and pretty deep, and pretty wide. That's gonna be interesting, but we'll see. But for now, I don't think I have enough time for an ASIC for Waterworld, and I'm afraid that's gonna be it for me for now.